Enthuse, and today we are going to see frictional force. And friction is not at all a bad thing. In fact, if you are a F1 racer, you will need that good grip on that road. You need that good handling, and that good handling comes because of friction. I'm pretty sure most of you like cars and racing, and many of you would have played many games like Need for Speed or Asphalt and things like that in your childhood and maybe even now. So you all know that friction is very, very important, and without friction you probably wouldn't have racing out there. So why not look at friction in detail with me? Shreyas, your master teacher for physics at Vedantu, going live from Bangalore. And I hope you guys are following me on my Instagram handle as well, where I keep posting regular updates about really cool things, all the different notifications that you would be interested in. When are my lectures? What kind of things am I doing? All that will be updated on Shreyas_Vedantu. So do not forget to follow me out there. So welcome everyone. How is my crowd? How are my kids? How are everyone? Come on, let me know. Welcome aboard. Welcome everyone. Well, Kirito, I don't know what trick or treat you're talking about. Hello Navmi, Tejas, Sonu, Rajesh, 70 Prashant, Vish, Tejas, Kashyap, Achyut, Arthi, VSG, Sai Pranav, Deepak, Unita, Harini. Okay, welcome Jumna. Hi Sai Reddy, welcome aboard. Okay, so do not forget to like and subscribe the channel, because if you do not like or subscribe, then YouTube won't recommend you the videos, and without your like and support, guys, please remember, we won't be able to survive. So please understand, your likes are the secret of our energy. So do not stop those likes. Keep pressing those likes, because I'm going to get all the energy from your likes, guys. We are not charging anything for this channel, from you. All right. Having said that, remember, I have also told you about the pro subscription course, where you get the additional benefits of 5,000 plus hours of learning, where you are getting enrolled in a long-term batch, and you also get your doubts solved from the doubt app, which will be applicable once you subscribe to this pro subscription. Not only that, you also get your test series, which are nationwide. You get a national rank. It's not a small rank that you get. Yes, you get the proper performance, because you'll be competing with all the kids of Vedantu spread throughout our country. And you'll be getting lots of assignments, because a lot of you are asking, sir, what about more questions? Don't worry, it's all there over here. And yes, you get continuous reports, and also you get personal teachers, and you have mentors, you have motivation sessions, just like we do over here. So you can get motivation from many more teachers out there, and you have an option to learn in Hindi or English, which many people don't give you. And also small term courses, which are called as micro courses, and special courses and crash courses for those students who want to speed up their preparation, who want to ace their performance in the last few months before the run up to the examinations. Thank you, Vish. Thank you. I love you too, guys. I love you too. The reason why I come here is because I feel like teaching. It's not because of anything else. It's just because of your support, your likes and your love, guys. That's why I come here. Thank you, Deepak. Thank you, Devash. All right, so the prices are as mentioned here. This is what you should pay attention to. The dropper students, it's 227 rupees per day if you subscribe for 6 months course, and it's 240 per month. 240 per day if you subscribe it for a month. And then the 2021 students, all the 12 standard students, it's around 173 rupees if you take a 6-month subscription. So 173 is what you pay per day. It's nothing. And the 11th standard students, you pay only 93 rupees if you take a 12-month subscription course. All right, per day. That's per day cost. Please keep that in mind. So it's very reasonable, and you're getting 20% off when you use this coupon code SHHPRO. Remember that. So the link is also there in the description. You can use the coupon code. The offer is valid for a limited time because of the festive season out here. All right. Well, Saurabh, I'll be soon teaching from my home. The studio is getting set up very soon, so don't worry. I'll be taking classes from my home. Today, I'm going live from the Bangalore studios. Yes, Shimon Sir's classes will also start from Monday. This problem is he's not in Bangalore. He's back to his hometown where the studio is getting set up. So it will take some time. Do not worry. He will be there too. Yes. So Jay, you can ping me on Instagram. I'll tell you everything. All right. Let's begin. And let's see what friction is. So guys, what exactly is friction? Is it a bad guy? Is it a good guy? I just told you friction is not a bad guy because a lot of people think friction is evil. Whenever something moves, it opposes. Yes, it opposes motion, but without friction, I wouldn't be able to hold this pen. This pen would have slipped out of my hand. Think about it. I wouldn't be able to walk anywhere. You wouldn't be able to sit on the chair because you would slide down that chair. You would not be able to hold anything. You won't be able to wear your clothes because everything will just slip off. Imagine, that would be such an embarrassment out there. All right. So understand, guys, friction is not a bad guy at all. So now let's see friction in detail. And some of you probably would have missed the Newton's laws session. In case you have missed, please attend those sessions, which would be there in the playlist down there. So you can get more knowledge on how to solve the problems of pulleys, constraints, and pseudo forces and all that stuff. So first, let's come to something called as the contact force, which I've talked about, but still I will do a quick revision because there could be many new students out here. So guys, whenever two surfaces are in contact, two objects are in contact, like you joining the hands, or you pressing against some wall, or you sitting on a chair, or you pulling a block on a surface. So whenever two surfaces are in contact, there is something called as a contact force. Now, why does this contact force come? Because the molecules of two surfaces come very close to each other. There is a strong electromagnetic repulsion, and these electromagnetic repulsions are in very different directions and different magnitudes. It depends on how these molecules are repelling each other, or how much they do not like each other. Depending on that, you will have these intermolecular forces which are there between the two surfaces. Now, when you add all these teeny meeny forces, there will be trillions and billions and zillions of such forces near the surface. The resultant of them, all right, the resultant of them is called as the contact force. So contact force will come obviously when there is contact, and is the resultant of those teeny meeny small electromagnetic forces when two surfaces come close by. Now, when you drop a perpendicular to the surface, remember guys, this is our surface. All right, these are the surfaces along this line. If I drop a perpendicular, the component of the contact force which is perpendicular to the common surface is called as normal, and that component which is along the surfaces is called as friction. Okay, so in a way, friction and normal are two components of the contact force, and like I have said before, contact force is the vector sum of normal plus the friction. This is vector equation, but if you want to talk about the magnitude, well, it will be n square plus f square. Understand that. Also keep in mind one more thing. If two surfaces are not in contact, okay, if two surfaces are not in contact, then let me add some special pointers out here. If there is no contact, then normal is 0 and even friction will be 0. Both the components will be 0. That's like obvious. And that's the principle of maglev trains. Maglev is a special train which is called as magnetic levitation train. So there are magnets or electromagnets which make sure that a train of that mass rises up in the air. So there is no contact between the tracks and the wheels of the train, and when there is no contact, there is no friction, so these trains can travel at a very high speed, more than I think around 400 kilometers per hour if I'm not wrong. Yes, it's there in Japan and Germany. if I recollect correctly. So these trains are based on this principle. The only force acting on them is air resistance force, but that is quite small as compared to the frictional force between the surface. Now what Tesla is trying to do using Hyperloop is even more crazy. He wants to not only eliminate friction, but he also wants to eliminate, yes, he wants to eliminate, guys, the air resistance force. So he wants to drive those trains in a vacuum tube when there is no air resistance. That would be crazy, that would be insane. And the speeds in the trials are astonishing. I mean, like, they plan to achieve speeds more than the speed of an aeroplane traditionally. That would be amazing if that happens. Anyways, coming back over here, understand one more concept over here. Okay, it just went off, but it's okay. One more concept. Okay. Okay, I need to be a little bit careful. Okay, so here is the thing. I just told you if there is no contact, then the normal and friction both are zero. But if there is contact, understand, normal is not zero, right? Normal will be there. All right, normal is there. Friction may be zero or non-zero. Yes, both are possible. How? Imagine you keep a block on a smooth surface. A block on a smooth surface will have normal, but friction won't be there. All right? Or even if, imagine there is just a block and the surface is rough. Yes, surface is rough. So what will be the different kind of forces acting on this block? One will be the gravitational pull, which is mg. Contact force will only have normal. The friction right now will be zero, even if this surface is rough. Yeah, let me tell you that. Why? Because if friction acts, let's say this way, then who is balancing friction? Nobody. There is no force which is balancing friction. So a block which is just kept at rest and nothing else is acting on it, and it's on a horizontal surface, the frictional force acting on it is zero, even if the surface is rough. So just because the surface is rough does not entitle it, does not make it qualify to actually get frictional force. Understand that. It's its privilege, but it's not necessary that it acts on it. I hope this difference is very clear. Just because the surface is rough does not mean friction acts. So that's why I said if two surfaces are in contact, normal will be there for sure, but friction may or may not be there even if the surface is rough. So that's a very important thing for you guys to understand. Amazing, Faizan, Krito, Sonu, VSG. Very good. You guys got it. Very regular students. I really appreciate so many students. I see so many regular names and you guys keep responding. I keep reading the chats and sometimes I cannot see the chats because I'm teaching. Believe me, after going home, I replay all your chats to see what and all you guys have said, everything. It's so encouraging, guys. Amazing. Keep the chat box flowing, and all the old time students, please help the new time students. And I can see many of you are already doing that. Help them out. That would be amazing. That's what we enthusiasts are for. Okay, so let's try to understand the different types of friction. Yes, there are two types of categories of friction. We categorize them into two different types. So first one is called as static friction. Look at this guy. He's pushing a block. Look at his feet. His feet stay intact. They are not moving unless and until he lifts it and puts it onto some other point. So there is some friction acting on his feet. Yes, but do not think that that friction is called kinetic. No, that friction is static. So what is this static friction? Static friction is that friction which acts between two surfaces when there is no relative motion. Yes, the two surfaces do not move with respect to each other. That time there is static friction. Example, me holding the pen. Yes, me holding the pen, guys. There is friction between my fingers and the pen. Is the pen moving relative to my fingers? No. So the friction acting is static friction. All right. But if the pen slowly starts to slide, or maybe I rub my hands, this friction is called as kinetic friction. So when I rub something, yes, I feel some friction. You can rub your body and feel that there is some friction out there. But you just try to press it, but let that hand not slide. That friction, guys, is static friction. So the friction acting on his legs is static friction, but the friction acting on the block right now, believe me, is kinetic friction, because yeah, the surfaces are sliding with respect to each other. So a lot of people think that when you walk, yeah, this is a common misconception, that when you walk, the force of friction is kinetic. That's completely wrong. Because when you walk, you do not drag your feet, right? You do not make that noise like kids do. You walk like a normal person. And when you walk like a normal person, your feet make instantaneous contact and they do not slide with respect to the surface. So it is static in nature. So let's try to identify different qualities. And before that, oh, by the way, let me show you this cool polar bear who is sliding very nicely. The kind of friction that he is experiencing is very small, but nonetheless, it is still kinetic in nature. Yes, Newton's third law is also valid here. Newton's third law has no exception. It is always valid. All right. So kinetic friction, good example. Even this, you grinding something, or a wheel spinning, a burnout, when you accelerate too much, that friction that is encountered out there in drag races or in very nice burnouts, that is kinetic in nature. I hope you get that. How do you differentiate between the two? That's why, Jay, I'm going to give you some pointers. Observe this. Observe this. All right. So look at this, guys. Imagine you have a block, okay, and you push the block with a force of 2 Newton force. You find that the block is at rest. If you find that the block is at rest, don't you think there will be friction acting on it? Obviously, yes. Which direction will the friction act? Think about it. Well, since according to Newton's first law, the body is maintaining its state of rest, the net force on it should be 0. So if a force acts this way, a counter force should act this way, and that should be 2 Newton, and this is nothing but your frictional force. So frictional force is also 2 Newton. That's how I guessed it. Now, what if I change the force to, let's say, 7 Newton? Okay. Now, I find that the body doesn't move. Well, if the body doesn't move, then also the force of friction should balance it because it is keeping it at rest. This time, the force of friction is 7 Newton. And because those two surfaces are not sliding, that is called as static friction. S stands for static. Now, understand, imagine I have a block and another block, and this block is moving at 2 meters per second, and even this block is moving at 2 meters per second. If there is friction between these two blocks, what kind of friction can exist? Yes, Saurav, you'll understand it now in this example. Yeah, what kind of friction, if at all it exists, will exist in this case? Think about it. No, it is not kinetic. Think about it. At this point, if there is any friction, it will be static in nature. So that's why, guys, a lot of people think, oh, whenever a body moves, it's kinetic. Whenever a body is stationary, it is static. No, wrong. What did I say? You didn't listen to me carefully. Listen to me carefully. I am saying whenever there is no relative motion, then the friction acting is static. Understand that. It is at rest with respect to this surface. So always look at both the surfaces in contact. But if this is on a ground, okay, if this is on a ground, then the friction acting over here will be kinetic in nature. So get the difference. Understood? So just because something moves does not mean it will have kinetic friction. You should see the relative motion between the surfaces. All right. So now, if I change this value slightly, let's say I make this as 3 meters per second. Now what do you think? Will this friction remain static or will this become kinetic, guys? Come on, let me know. Yes, friction will not affect the inertia. Manju, inertia is a separate property. Yes, now it will no longer be static. Now it will turn into kinetic nature. Very good, because now there is relative motion. Excellent. You guys got it. You guys got it. Excellent. So now let me give you the notes over here. And the notes are: static friction acts when there is, you can keep making notes, that's the habit which you have to follow, when there is no relative motion. Okay, so that's when it acts between the surfaces. Next, what is the direction? The direction of the static friction is always opposite to the tendency. See, what is the meaning of the word tendency? Tendency is something what you want to do. Like probably somebody might want to run out of the house and play cricket right now, or maybe just run out of the room and watch that IPL match. That's your tendency. So friction will always oppose that tendency. Example, imagine I have this phone, okay? So this is my phone, and look at this. I'm risking my phone, guys, for you, so you better pay attention. I'm holding the phone like this. Is it sliding down? No. What does it want to do? It wants to slide down, but it is not sliding down. So the tendency is this way. So friction is opposing the tendency upwards. So that is the direction in which friction will act. I hope this is clear. Yes. Don't worry, even if it falls, there is a carpet down. So I hope it will be safe. Anyways, I dropped my phone many times. Okay. So it always opposes the tendency. Another important thing, it is a self-adjusting force. Just before some time I told you, yes, friction is self-adjusting. When I put 2 Newton, the friction was 2. When I applied 7 Newton, the friction was 7 Newton. So it is adjusting itself. So I'll just put a pointer over here. It is self-adjusting. Okay. Now just imagine this. Just imagine this. Just imagine that there is a heavy block. All right. So there is a heavy block, and I try to push this block. I apply 2 Newton, it doesn't move. So the friction is 2 Newton this way. I apply 7 Newton, friction is 7 Newton. Okay, adjusted. I applied 10 Newton, it still didn't move. So friction has adjusted itself to 10 Newton. Now I apply 11 Newton, this block starts moving. You know what this block has done? It gave up. It's like, okay, sorry boss, I will move now. Okay, that's what it said. So why did it say that? Because there is a limit to that. So there is a limiting friction. Friction can only exceed or keep on adjusting till a particular limit. Beyond that limit, yes, that is called as limiting friction, and that limiting friction is called as Fs max. So Fs max is called as the limit or the limiting static friction, and this limiting static friction is given by the formula a constant μs into n. So what is n? The normal force, right? So n is the normal force. μs is called as the coefficient of static friction. Now you'll be like, sir, what is the value of mu? Please tell me. Well, I can't tell you. You'll be like, sir, why are you so mean? No, I'm not mean. I really don't know, because it depends on the surface. Yes. So if it's wood and wood, it could be something. If it's glass and wood, it could be something. If it's rubber and road, it could be something else. So yes, this value of μs depends on the surfaces. And do not worry, it will be given to you. Like 0.6, 0.3, 0.9, etc. It will be given to you. Do not worry about it. Alright? So you'll be like, sir, what if the value of mu is large? Well, don't worry, the friction is large. That's all. What if the mu value is 0? Oh, don't worry at all, it's perfectly smooth. So a large value of mu tells me that its adjusting capacity is good. Yes, its adjusting capacity is very good. So you can apply a large force and it will still not budge. But a small value of mu tells me that, okay, a small force only can probably make it moving. That's what it means. Yes, so everyone has limiting friction. Yes, sabka hota hai. There is one limit. Bas, iske baad I will not be able to bear. Yes, everybody has that limit. After that, you Ata Maji Satakli. Yes, basically Fs max is Ata Maji Satakli. If you have watched that movie, Singham, Ajay Devgan's movie, yeah. Yes, so at Fs max, it is Ata Maji Satakli. Understand that. Okay, great. So mu dependent on n? No, mu is not dependent on n. Mu is not dependent on n. Understand that. All right. Mu is not dependent on n. Understand. They're two different things. Amazing, guys. Let's go ahead. I have some cool thing to show you. Keep watching. I have some cool thing to show you. So that was static friction. I hope you have made notes. Let's go ahead. Yes, kinetic friction. Let's make notes for kinetic friction quickly, because I want to get to problems. Oh, wait, Pandu, your turn is not yet come. 1 second. You'll have to hold on for some time. Okay, let's talk about kinetic friction. So what about kinetic friction? It will act when there is relative motion. So it acts when there is relative motion, and that's what we have seen. So when two surfaces move relative to each other, yes, there is kinetic friction. Okay, next, what is the direction? Well, the direction of kinetic friction is always opposite to, not tendency. No, not tendency, because it is actually moving. So there is nothing like tendency. It's actually opposite to the relative motion. You can try this out. Imagine you can take your phone, if you have it, and keep it on an inclined plane. Matlab, your hand itself. And oh my god, my phone is not falling. It's got some crazy grip, huh? Okay, let me keep it like this. Maybe it will fall. Okay. So I see that at a particular angle it starts, wow, it's got some crazy friction, or my hands are very sticky, maybe I'm Spider-Man. Anyways, so basically you will see at a particular angle it starts sliding, and when it starts sliding, the actual motion is here. So the frictional force on the mobile phone, think about it. Yes, the frictional force on the mobile phone will be upwards because the motion is here, so friction will act up. All right, now pay attention to what I'm saying, because this is very tricky, the whatever statement I'm going to make. On the phone, because phone is going down, the force is upwards. But guys, think about the hand. Please don't leave the hand, guys. Come on. By Newton's third law, think about it. On the hand, the frictional force is down. You can feel it. You can just take some block or some, maybe if your brother or sister is around, take his or her phone. They will shout at you, but that's okay. So try it out, and you will see that as the phone slips out of your hand, the friction will be upwards on the mobile, but on your hand it will be downwards. Action, reaction. That's how it is. That's how it is. I hope you guys are getting it. Manju, I hope you understood it right now. Yeah? So action, reaction. It always acts opposite. Yes. So for the mobile phone, the hand is moving up. So for the hand, the friction will be down. For the hand, the mobile is going down, so the friction is up. That's how it works. Amazing, amazing. So it always opposes relative motion. That's something what we saw. It's not adjusting. No, it doesn't adjust. It's a constant force, right? It does not adjust itself. Once an object starts moving, it becomes a constant force. And what is the value of that kinetic friction? Well, the value of the kinetic friction is mu k into n. Yes, it is mu k into n. So this is the force of kinetic friction which acts on a body. What is this mu k? Again, it's a coefficient of kinetic friction. And you will be like, sir, what is the value of mu k? Remember, I'm not mean, but I really don't know. It depends on the surface again. It depends on the surface. You cannot do anything about it. Depends on the surface. All right. So a larger mu tells me that the surface is very rough. A smaller mu tells me the surface is not so rough. And it again depends on the normal, the frictional force. More the normal, more the friction. So if an object is really heavy, it will be interlocking the surface really hard, and that's why the friction that it will encounter will be very large. All right. I hope this is clear. Amazing. So what about mu k and mu s? If somebody wants to know, well, let me tell you one important thing. The value of mu k is generally less than the value of mu s. All right. Generally, the value of mu k is less than mu s because understand, mu s is coefficient of static friction, right? It's always harder to start motion than to maintain motion. Think about what I just said. Think about it. Karan, that is not the actual statement. The actual statement is, if two surfaces are polished beyond a limit, then the friction actually increases, because when you polish it too much, then the molecules start attracting each other, they won't leave each other, and that's why the friction increases. Very good, very good. So let me show you something, and then let's go to Pandu problems. Are you guys ready for this cool simulation? Then we'll go to Pandu problems. Okay, so let's look at a very interesting thing. I will be not on the screen, please keep that in mind, because I'll be sitting and playing that simulation for you. So watch carefully. I am not going to play this again and again, all right? And if you miss it, please replay this back after the session ends. Okay, so pay attention, guys. We have a person. I hope you can see him. In case you can't, I can't zoom onto him too much, but that's it. Yeah. All right. So I can't zoom too much, but I hope you are able to see it. All right. Okay. Can you see it, guys? Are you able to see it? I can read all your chats, by the way. I'm not on the screen, but I hope you can see it. Yes? Okay. Science Priya, Navami, yes. Okay. Now, let's make the surface very smooth. Let's make the surface very smooth. Let's see what the mass of the box is. It is 50 kg. In case you cannot read it, speed is 0. Force is right now 0. It's very small, but I hope you can see it. In case you cannot, I'm just telling it to you. Now, let's apply a force. How much force? 50 Newton. Look at that. The speed is increasing. Yes. When there is force, there is acceleration. Now, let's get rid of that force. Oh, bye-bye. Bye-bye. Okay. So, look at that speed. Speed is constant. And why is the speed constant? Because the force is 0. A body in motion maintains its state of motion unless and until acted upon by an unbalanced force. There you go. An unbalanced force acts on it, retards it, stops it, stop. And if I continue applying that force, now it starts going in the opposite direction. Yes, it is accelerating backwards. And if I now apply more force, it will accelerate even more. And if I now remove the force, okay, bye-bye, dude. So you can see that the speed remains constant. That is what it is. Is this clear? This was without friction. Now, let's see with friction. Was that clear, guys? Everyone? Let's see with friction now. All right? So stay tuned. So let's see with friction. Let's add some friction. Okay? Let's see the speed, the mass, the values, and the sum of the forces. Let's apply 1 Newton force. Nothing. 2 Newton. Nothing. Look at that. As and when I increase the force, the frictional force is also increasing. I hope you can see that. I can apply even 50 Newton force. It does not change. Don't you see that as I change my applied force, the frictional force is also adjusting itself? Now, if that's so, what about in the backward direction? If I push it from here, friction changes its direction. If I apply more force, friction adjusts itself. If I push it this side to 100 Newton, again the friction changes its direction. Now, let's apply slightly more. Let's see when does it start moving. When does it start moving? Keep a tap on the speed. The moment you see that it has some speed, we have reached the limit. So, okay. Oh, there it started moving. There it started moving. So, 125. Yes, guys. So, 125 was, okay. 125 was the FS max. I hope you saw that. In case you did not see it, watch it again. 75, 125. It doesn't move at 125. 125 is its limit. 126, it starts moving. That's it. It starts moving. And notice one more thing. The moment my applied force crosses the FS max, and once it starts moving, look at the frictional force. I am pretty sure you cannot see it, but I can read it out for you. The force is, guys, 94 Newton. What is that 94 Newton? Kinetic friction. So kinetic friction, remember I told you it is always constant. Okay, so I can do it this way also. Okay, observe this, 100 and more 150 Newton. Look at this, the frictional force is just 94 Newton. That's why the net force is here. Now, if I want to make it move with constant speed, believe me, what I need to do is, I need to reduce my force to 94 Newton. Look at that. When my applied force is 94 Newton, net force is 0, the speed remains constant. That is what I told you. It's harder to move something, start the motion, than to keep it moving. That's what you will see. And if I remove that force completely, okay, if I remove that force completely, that's it. The force will act till it stops. Once it stops, that's it. No friction. Remember, the surface is rough, but still there is no friction. That's how this works. I hope this animation has made things very clear. No, it's not a video game. Nobody makes such a video game. It's a simulation called as PhET. You can see it on the internet as well. PhET. All right. Clear, Dhadak, Krito, Sai. Yes, Sai, we are coming to questions. Thank you, Jumna, Navmi. Okay, very good, Saurabh. Glad you guys are understanding. Let's get Pandu. Let's make him do some work. So Pandu is pushing a table of mass 20 kg. First, I'm starting very simple problems and I have some amazing questions for you. So hold on. Let me get these concepts clear first with you guys. So Pandu is pushing a table of mass 20 kg. What will be the minimum force to get the table moving? Mu s is also given, mu k is also given. What did I tell you? All these values are always given to you. Okay, great. So let's see. Let's start with the free body diagram. Whose free body diagram? Obviously tables. So what is the mass of the table? 20 kg. So let's draw 20 g over here. Amazing. There will be also normal force from all the legs of the table. So let me show the normal force like this. Obviously Pandu is pushing him. So there is a push. I can call it P. All right. That's also a force. And the question is, what is the minimum force to get the table moving? Now, when such questions are asked, always see to it that your force is just balancing the limiting force. Once your force just balances the limiting force, any force above that value will be okay to make that table move. All right. So where will friction act? Obviously, it will act like this. And what will be the friction? It will not be any ordinary friction. It will be Fs max friction. Why? Because you want to find that minimum force to make it move. So when you apply that force, it will be at its limit, at its peak, it will be limiting friction. That's it. So P will be, it's not moving. Please understand right now, it's still at rest. Anything more than P will make it move. Keep that in mind. So P will be equal to Fs max. Therefore, Fs max, remember, was mu s into n. I just gave you the formula. And what is mu s? Well, that is 0.5. And what is normal? Oh, that's 20 g. 20 into g. G is 10. So what will this be? Come on. It will be 100 Newton. Very good. So 100 Newton is the minimum force required to make the table move. Anything above 100 will definitely make it move. I hope this is clear. Let's go to the next part of the question. Amazing. I can see all the answers coming in the chat box. Now, what will be the frictional force if Pandu's force is only 20 Newton? Yes, Pandu's force is only 20 Newton. He is applying only 20 Newton force. All right. So you have that normal and you have that weight over here. So what do you think will be the friction? Do you think it will be Fs max? I don't think so. It will be Fs max. It will be just Fs. Why is it Fs? Because 20 Newton is less than Fs max. So it has not yet reached the limit. Remember, Fs max, we just calculated it to be 100 Newton. So the frictional force will be exactly equal to 20 Newton because it is self-adjusting. It's within the limits, so it is going to adjust itself. Amazing. Easy. Let's go ahead. I'm just talking about the magnitude. I know direction is opposite, or I have shown it in the diagram. So Karan, if the question is asked that what is the minimum force required to make it move, you will answer it as 100. Because in the options, you will get 100, 200, 150 like that. So you will mark it as 100. Do not mark, oh 100 pe to move nahi hoga. So the meaning of minimum is That's the least value. Anything above that, it will move. All right? Okay, next. If the table is moving with a constant velocity, remember that simulation? Same thing. How much force is applied by Pandu? Okay, so now the table is moving. Important keyword to remember is that constant velocity. If the velocity is constant, isn't acceleration zero? Right? So the table might be moving, guys, with constant velocity, but because the velocity is constant, remember the acceleration is zero. Great. So if acceleration is zero, what can I tell about the table? Well, there is normal, there is mg. What is m? It's 20, so 20g. There is that Pandu's push, and the friction acting is no longer static, it is kinetic in nature. Hence, P minus Fk will be mass into acceleration, which is zero. So therefore, P will be equal to Fk. And what is Fk? It is mu k into normal. And what is mu k? That is 0.4. And what is normal? Well, that is 20 into g, which is 10. All right. And that will become how much? 80 Newton. You can see, to keep it moving, you need only 80 Newton force. But to start the motion, you needed more force. That's how you make the calculations. I hope concepts are getting clear as you solve this problem. Shall we go ahead? All right. Chalo. Let's go to the next part. Once the table is moving, very important word, what will be the acceleration of the table if Pandu pushes it by applying a force of 100 Newton? 100 Newton was the force required to make it move. But let's say it's started its motion, it started its journey. So then what would be the acceleration? So since it is moving, understand it might have some acceleration. All right, there is normal, there is what is that weight? Is it 20 kg? Yes, it was 20 kg, matlab 20g. There is my push, which is 100 Newton, but the friction will not be static, it will be kinetic. So in this situation, I will say 100 minus Fk will be mass into acceleration. That's the change. So therefore, it will become 100 minus, what is the kinetic friction? Well, that is 0.4 multiplied by n. What is n? That is 20 into g is equal to 20 multiplied by a. I hope this is clear. So therefore, it will be 100 minus 80, correct, is equal to 20a. So therefore, 100 minus 80 is 20, 20 cancels, and you'll get it as 1 meter per second square. Amazing, Achyut, Karan, very good, very good. Jay, you can take the screenshot later on also, don't worry. Don't worry, the lecture is always recorded, okay? Don't worry. Because these are easy, that's why. Okay, no problem. If you want, I'll give you some more time. No problem. Okay, clear? Chalo, let's go to next problem. Okay, now remember the graph of static, okay, static and kinetic friction. When you apply more force, static friction adjusts till the tipping point, and then the friction suddenly drops into the kinetic zone. So this is a graph which is very obvious, and from the simulation especially, it's very, very clear. Okay, fine. So now let's go to some inclined plane problems. Okay, now the minimum angle of the inclined plane for which the block starts sliding. Let's figure this out. And this, by the way, that angle, that minimum angle, I'm going to call it as alpha. That angle is called as the angle of repose. So it is that minimum angle at which a block starts sliding, and let's say that angle is alpha. Let's draw the free body diagram of this mass. Well, it will encounter normal force here. Mg will act down, but I can split it into two components. We have been doing this many times, so I'm just going to skip that step, and it will be mg sine alpha over here, and downwards it will be mg cos alpha. When it is on the verge of sliding, think about it, the friction acting will be upwards, and it will be the limiting friction. Why limiting friction, guys? When I keep increasing the angle, gravity will pull it more and more and more. And then the moment gravitational force just is at the tipping point and it is just balancing the limiting friction, that's when it is on the verge of sliding. Anjali, I'll recommend it some other time. I have in fact made a video also on that, how to score 200 plus in JEE mains. You can just watch that. I've recommended books in there. Okay, so just concentrate right now. All right. So when it is on the verge of sliding, understand acceleration is 0. It's not slided yet. So hence mg sine alpha will be equal to Fs max. And what is Fs max? We just saw it. It is mu s into n. And what is mu s? Just keep it as mu s. What is n? N is nothing but mg cos alpha. So here you have mg sine alpha. Here you have mu s mg cos alpha. Mg goes, and cos can be taken below. So it will become tan alpha is equal to mu s. So this is the angle. And you should remember this result. Yes, Karan, I agree with you. Yeah, tan alpha. Remember this value. Now, what is the significance of this value? Number one, it's independent of gravity and mass. So, understand, this block will slide on this surface at the same angle even on moon, because G is not there. Yes, and even in lift. So in lift, what happens? G changes, right? So even in a lift, this block will slide at the exact same angle. Angle of repose does not change. All right. So having said that, let's go ahead. Very important. Now we just solve this. Okay. How about this problem? Let's complicate. Now I'm coming to some complicated problems. There are some amazing problems planned for you. So pay attention. Yes, insane. You can definitely do HCV in 10th also. Okay. Now I want to solve this problem. There is a block, there is friction, there is a mass. This angle is 37 degrees, and I want to figure out what is the acceleration. What is one way of doing it? One way is drawing the free body diagrams separately. Okay. So we'll draw the free body diagrams, but think, where will it move? I feel that it will go down. If at all it has to move, this 5m will come here, m will go up, right? It will go down like this. So you can draw FBDs, make equations. Like, for example, this 2m will experience 2 mg and a tension upwards. All right, that's this mass, and it will have some acceleration downwards. This 5m will have two components of gravity. One is mg cos 37, and this one is mg sine 37. And of course there is a normal and there is a tension. But since there are two strings, so do not forget to take two different tensions. This is not the same string throughout. This is one string, this is the second string. So do not forget to take T1 and T2, and there will be tension T2 from up, and it will be also accelerating this way, just like this 2m is accelerating here. And then this m will have mg down, and this will have T2 up, and this will have acceleration here. And now I believe the FBD, oh, one more thing is there, and that is the friction. So friction will act here, and what will be the value of friction? It will be mu, which is 0.1 into n. So that is the value of frictional force if it is sliding. Great. Yes, so finally you have friction. Now that you have these FBDs, you can start making equations like 2mg minus T1 is equal to 2m into A. That's one equation. Then for this guy, T1 plus mg sine 37 minus T2 minus friction is equal to, which is 0.1 into n, is equal to 5m into A. That's another equation. All right, T1 plus this minus this is equal to 5m into acceleration this way. And the last one for this, it will be T2 minus mg is equal to m into A. Solving these three equations, you can find the value of acceleration. which you cannot take single tension because the threads only are different. It will not be correct. Okay, now let's see the answer, Karan, don't worry. Yes, Saurav, let's see the shortcut method. So this was one way of doing it, and we know that solving it by that lengthy method is quite tedious, and that's why I gave you the opening up method, haven't I? So how about looking at it through opening up method, and that will make things really easy. Let's try this out by opening up method, and here it comes. Just open everything up, and guys, things look so simple now, believe me. So mg, which was acting here, will tilt like this, correct? So this mg will be here. Please remember, my system is this entire thing. Yes, this entire thing is my system. Okay, and this system is moving like this. Everything is moving like that. Keep that in mind. Okay, tensions won't matter, it is internal force. This 2m was experiencing an external gravity. When I tilted it like this, I opened it, it was having a 2 mg force here. This 5m, well, this force won't matter because that is not causing any motion in this direction. Just look at this force, the external force. What was it? 5 mg sine 37. So there will be one external force of 5 mg sine 37. And if you remember the value of sine 37, recollect sine 37, guys, was 3 by 5. So 5 and 5 gets cancelled. So it will become 3 mg. That's one force. And remember, there was a friction this way. So when you tilt it like that, that friction will also come. And what is the value of friction? 0.1, that was the coefficient, multiplied by n. And what was the value of n, guys? What was the value of n? Think about it. It was 5 mg. Yes, n was 5 mg cos 37. And what is cos 37? 4 by 5. So normal will become 4 mg. I hope this is clear. So yes, this will become 0.1 into 4 mg. Now it's a simple problem. There is nothing great about it. Remember, what did I tell you? Acceleration is pulling forces minus opposing forces upon total mass. What is the pulling force? 2 mg. Then next 3 mg. Anything else? I believe nothing else. Okay, so then this friction is opposing force, so it will be nothing but 0.4 mg and that mg over there, minus mg, upon total mass 2m plus 5m plus m. Okay, what will I get? 2 plus 3, 5. 5 minus 1, 4. 4 minus 0.4. 4 minus 0.4, guys, come on. 3.6 mg. I hope that is correct. 5, 4, okay, yes, 3.6. And this is 2 plus 5, 7. 7 plus 1, 8. So divided by 8. And that m also gets cancelled from the top and the bottom. So I'll get it as 3.6 divided by 8. Yes. So you can substitute the values and solve it, but that is the answer. Isn't it simple? Did you like this method? Did you guys like this method? So give a like, yeah? Hit that, smash that like button down there. Yes, if you like this method. Amazing. What a method. Amazing, guys. Amazing. Chalo. Let's see, this is what you will learn in JEE Enthuse. Nobody is going to teach you all these methods. Even in many coachings, they won't teach you all this. So if you stay regular, you are going to ace JEE mains. Be it next year, next to next year, whatever. You're going to ace JEE mains with me. Yeah, no problem. Some people forgot to multiply with mu. Koi baat nahi. Now let's see block on block problems. A lot of people. Yes, Shubhangi, the PDF of this session will be there below in the description link. And my notes. Yes, a lot of you have sent me personal messages on Instagram. I really thank you guys, appreciating all my efforts. So thank you again, sincerely from the bottom of my heart. They have liked the summaries of the chapter, which we call it as extracts. So extracts will come again today for Newton's laws and friction. Yes, yes. Anu, believe me, and Gopal, Pramesh, next Saturday I'm going to keep an advanced session. Yes, an advanced session for solving problems. Advanced session for solving problems on kinematics. Very difficult problems. ऐसा हिल जाएगा, मतलब you will be like shocked. Oh my god, how to solve this problem? Those kind of problems are coming next Saturday, so stay tuned. Yes. Okay. See guys, the reason why, yes, for all topics, Saurav, I will keep a gap of 1 week so that you get used to it. Like last week we did kinematics, so next week you will have advanced session. So this week we are doing Newton's laws. Next week you will have Newton's laws advanced session. So you will have a gap so that you can revise practice problems. Thank you, Gopal. Let's solve this problem. Come on guys, let's solve this problem. A small block of mass 1 kg placed on another block of mass 5 kg and length 20 centimeter. What would be the value of F so that the block doesn't slide? Come on, let's do this quickly. Let's do this quickly. Think, this surface is smooth. There is friction here. I'm pushing this block. This block would try to fall back like that. Correct? Think about it. If I push it, it would try to fall back. But if I apply too much force, if I apply decent force, if I'm decent, then this block might not fall. So the question is, what is the maximum decent force you can apply? All right. So let's see what is the maximum decent force that we can apply so that the block doesn't slide. So for doing that, we have to obviously start with free body diagram. That's our usual business. So let's go about it. So let's see. What do we do? What do we do? What do we do? Let's look at block B, because this is a culprit out there. That guy wants to slide. So how do I look at it? Where do I sit and look at it? I will sit on block A and then look at B. Yes, I am going to sit on block A and then look at block B. Why? Because then it looks easy. If I sit on this block and look at B, I feel that, okay, somebody is pushing that block B behind. Who is pushing? We all know. Who is the culprit? Pseudo force. Why? Because this A is a non-inertial frame and there will be a pseudo force this way, because this block A and B together, yes, this combined system together is going to accelerate this way. And if I want to calculate that acceleration, it's not that difficult. F will be equal to mass 5 plus 1. So 5 plus 1 into A, so which is nothing but 6A. So that force which I'm applying is 6A. I know somebody might be thinking, sir, what happened to the friction? Where is it? Well, it's here. So why didn't you take? This is internal force. So why should I take? Only external forces will come. Sir, then what about the friction here? Read the question carefully. There is no friction anywhere else apart from between A and B. Floor is smooth. So keep that in mind. So that's why the only force external horizontally is F. Nothing else. Nothing else. Good one, Karan. Anyways. Now, once we think about the pseudo force, the magnitude will be mass of block B, which is 1 into A. That's the value of pseudo force, and it is backwards because the system is accelerating there. Pseudo force will be there. So there you are quite late, but don't worry, join in. It's okay. You will understand whatever you can. Okay, block B will experience mg, that is 1g, and normal on that block. What else? What else? What else? Where will be friction? Friction will be here, and friction's maximum value, right? So that it doesn't slip. So it will be Fs max will be mu, which is given 0.5 into n. But wait a minute. What is the value of n? N is 1g. So it is nothing but 1g. What is g? 10. 10 into 0.5 is just 5. So 5 Newton is the answer for Fs max. Okay, we are not done yet. Now, if Fs max is 5 Newton, what will be Fp? Think about it. These both will be balancing each other. And from this frame, it will appear to be at rest. Yes, it wants to slide back, but it is not able to slide back. So Fp, right, that implies Fp will also be Fs max, which is 5 Newton. Now, once I know what is Fp, I'll just put the value of that. That is 1 multiplied by A. But wait a minute. If A is 5, then, so therefore A is equal to 5 meters per second square. I think I can put it over here and I can immediately get the value of F. So what will be F? 6A, 6 5s are 30. So 30 newtons is the answer. I hope this is clear. Sometimes this N can be confusing with that unit, so I'll put it as NB. That will be better, so that you do not confuse between this N and that unit out there. Mohammad Shimon sir ke ghar pe, you know, the studio is being set up. That's why. He will come. Don't worry. Monday. Okay. Very good, Prajwal. Come on, join in. Let's do the next part. Are you guys ready for the next part? Okay. Let's do the next part now. Next part is very tricky. A lot of people struggle. They are like, my God, what the hell is this problem? Observe. Block, same thing. Another block, same thing. Length, 20 centimeter. That's it. 0.2 meters. Initially, block B is near the right end. Now, you push. Okay. This had to be changed. So I'm changing it here. Assume previous value of F multiplied by 2. What was the previous value of F that I got? 30 Newton. So F multiplied by 2, which is basically 60 Newton. Remember, when I pushed it by 30 Newton, block B did not slide. Okay, I'm changing the question a little bit because there was an error there. If I push it by 60 Newton, won't block B slide? Obviously it will slide. Now the question is, how much time will block B take to come onto the other side? Very good question. This is in fact one of the second last or last problem in HC Verma also in exercises. Different values but similar concept. Okay, so let's see how to solve this. Now, obviously I have to start with the free body diagram. So let's start with the free body diagram. Okay, now there is one very important catch which not many people realize. Yes, not many people realize. You know what's the catch? You cannot take this entire thing as a system. Why? Because they are not moving together. Yes. So understand, because your force is twice as before, the blocks do not move together. Hold on, VSG is not so simple. Understand first. Yes, pseudo force only will use Saurav, but there are many tricks here and traps rather. So understand, their accelerations won't be the same. There is relative motion between them. Okay, so now what do we do? Well. Now we are in big trouble. Let's draw block B's FBD. Oh, sorry, that was block A, my bad. Block A's FBD and see what and all forces are acting on it. All right, so let's see what are the different forces acting on block A. On block A, you have that 60 Newton force. Okay, great. Next, you have A's own weight. What is A's weight? 5 kg. So 5g down. Be careful. Observe this. It's not so simple, VSG. Observe. Block B will also exert its normal. How much will be the normal? Think about it. This is NB, let's say. And this NB, guys, will be equal to the weight of B block. B block's weight is 1g. So NB will also be 10 Newton. So there will be NB over here. And that NB will obviously be 10 Newton. Now, apart from that, is there a friction down here? No, because the floor is smooth. That's given. But there will be friction here. Yes, on that green top surface, there will be friction. What is the direction of pseudo force? You should use which when you are sitting in a non-inertial frame. Okay, you are a non-inertial observer. That's when you use pseudo force. That's what I taught in the previous class. Okay, so Pandu Champa love story and all that. Okay, so that's not so simple. So let's see what to do. Yes, and NA of course from below and NA from here. Okay, to figure out the direction of friction, just visualize yourself on A. Visualize yourself on the block A. What will you see the block B doing? When you're sitting on A, Yes, you are pushed forward. So block B will be seen going that way, right? Block B will be seen going that way. And why is block B going that way? Because of the pseudo force. And what will be the pseudo force? Think very carefully. Think very carefully. Well, let me tell you. This block A will have some acceleration, right? Let's say I call it A1. Believe me, this pseudo force will be mass of this block. Yes, this block, which is 1, multiplied by A1, because you are sitting on block A. Understand this. Non-inertial frame's acceleration, how much is it? It's A1. So pseudo force will be mass into A1. Understand that. Now, if you have got this till here, everyone got it? Everyone got it? Achyut, think about it. Pseudo force is what? Mass of the body into acceleration of the frame. Where are you sitting? On block A. What is A's acceleration? A's acceleration is A1. A's acceleration is A1. That's why pseudo force is mass of B into acceleration of the frame. That's why. Amazing. This is the tricky part. Don't worry, you're going to get there. Now, there are more forces acting on it. If pseudo force is there, it will end up accelerating that way, correct? And let's say the acceleration is something like small a. Okay, small a. There will be also this friction, right? Over here. There will be also this friction, that kinetic friction. And how much will it be? Think about it. It will be 0.5 multiplied by that normal. And how much will it that be? That will be 5 Newton. Got it? Very good, very good. So this A, understand, is not the actual acceleration. This A is, understand, the relative acceleration from this frame of A. No, acceleration is not opposite to FP. Acceleration is in the direction of FP. But this is not the acceleration of the frame, small a. Small a is the acceleration of block B. That's the difference. Yes, it's the relative acceleration. So get that thing straight. I hope this is clear. I hope this is clear. Only then I can proceed ahead. Got it, everyone? Now, once I know friction is here, that's it. My job is done. On block A, the friction will be here. That's action-reaction pair. Yes, these two are action and reaction pair. Think about it. That is action and reaction pair. Very good. So on block B, friction is here. So on block A, the friction will be here. That's how you should approach this diagram. Yes, yes. We have to apply relative motion also. Wait a minute. First, let's solve this. Now, how do we get this A? I need this A. How do we get this A? To solve this, I need A1. And first, let's get A1 from this guy and see what is the answer. Okay, let's try and solve for A1 from this block A. So for block number A, my equation will look like this: 60 minus this kinetic friction. What is that kinetic friction? 5 is equal to mass of the block A. How much is it? 5. 5 multiplied by A1. Just see this. Just see this. If you guys are understanding this, everyone fine? 60 minus frictional force is equal to mass into acceleration. Nothing great about it. Thank you, Manju. What is this? 55 is equal to 5 A1. So A1 is equal to 11 meters per second square. That's what I got. Acceleration as amazing. Now use this A1 over here. So pseudo force will be 1 into 11. So it will be 11 Newton. Now apply it for block B. Okay. So now let's apply it for block B. So for block B, guys, for block B, 11 Newton is in the direction of acceleration. Just think as if it is on the ground. There is a force which is pushing the block B behind, which is pseudo force, minus frictional force, which is 5, is equal to mass, which is 1, into acceleration, which I do not know. 11 minus 5, 6. So acceleration is 6 meters per second square. Amazing? Amazing? Now the last part. It's not done yet. The question is, find the time before it goes till the other end. That's it. Now the job is done. If you are sitting on block A, you see the block B moving like that. With what acceleration? 6. So which equation will you use? Kinematic equations. Remember, kinematic equation will also be applicable in relative frame. So let's apply that. Yes, let's apply kinematic equation. So S is ut plus half at square. So what is S? That 0.2, I believe. That's somewhere given somewhere. Yes, length is 20 centimeter. So it is 0.2. U is 0 because it starts from rest. Half into 6 into t square. 6 by 2, 3. 3 goes there. So this 0.2, I can write it as 1 by 5. So this 3 comes down. So it will become 1 by 15. Okay, if you're not understanding, 1 by 5 into 1 by 3 is equal to t square. So therefore, t is equal to 1 by root 15 seconds. That's the final answer. That's the final answer. What an amazing problem. It cleared so many concepts. It is difficult to understand. Yes, it is difficult to understand. And trust me, I have tried every possible means to explain this to you. Manju, which standard are you in? Are you very new? If you are very new, then probably yes, it is fast for you. But if you have some idea about Newton's laws, if you have been attending my classes regularly, it should not be very fast. Please revise, Manju. Thoda push karo. You have to push yourself. You are not babies anymore. You have to push yourself because JEE is difficult. If it was easy exam, then everybody would be an IITian. Hai na? So you have to push yourself. It's difficult, but you are going to do it. Okay, Manju, but push yourself. No, this is not JEE mains level. This is JEE advanced level. So this is the kind of questions I'm going to do next Saturday also. Okay. So now, this question is for homework. This is homework question. Thank you, Gopal. Thank you so much. Love from my side too. This question is homework. Let's see how many of you can solve this. Mention the answer in the comment box. Yes, in the comments, not in the chat box. In the comment box. I'll be reading all the chats. All the comments. Oh, Manju, you two are from Pune. Amchi Pune. Kya baat hai? Kasa kai bara hai? All right. So, guys, if you want to join the pro subscription, the link is below, and I have also told you the coupon code, which is SHHPRO. Do not forget to use that. If you want 20% discount, which is this season sale going on right away. If you want all kinds of amazing courses, amazing teachers, assignments, tests, everything. And yes, Telegram group link, a lot of you keep asking, it's there below in the description. And this is the link through which you will get all the notifications, updates, everything. And if you have enjoyed today's session, do not forget to like. And if you're a new user and you want to learn more, do not forget to subscribe. All right. So that's it from me. I'll be going live on the V Biotonic channel. Yes. For special guidance on how to remember physics formulas at 9 p.m. tonight. Yes, Vedantu Biotonic channel for NEET. So if you want to join in, yes, you can join in. I'll be seeing you there in 45 minutes from now. Bye-bye. Take care. See you. And stay home and stay safe, guys. Bye-bye. See you.